Good morning, good afternoon, good evening, boys and girls. Happy Monday or Tuesday or Wednesday or whatever day it is you're watching this lesson. All right, for science this week, we're going to be talking and learning about force and motion. Force and motion is something that we covered over the first 6 weeks, so this should be a review for you. So let's get started. All right, so when you open up your activities for this week, this is the first page that you see right here. Oh, see, there's my finger. Yay, it only took 30 seconds. And it's going to be a lot like it was last week, where you are going to just open this every single day and complete it by the end of the week. Remember that you do not click the turn in button until the very end of the week when you have absolutely finished everything. Some of the items that you're going to need for this week, an egg carton shell that's empty, or a plastic container or an empty box of some sort, maybe some foil or saran wrap, a sock, washcloth, paper towel, and then other household items like an empty box, a book, a cookie sheet, maybe some cardboard, coins, rocks, glue, scissors, tape, things like that. You'll kind of see when I'm showing you how we're doing our lab this week, what some of the different items that you can use. All right, and we are looking at force and motion. We will design a descriptive investigation to explore the effect of force on an object, such as a push, which is away, or a pull, which is towards. We'll also look at gravity, friction, and magnetism. All right, so starting off today, looking at and thinking about your favorite equipment, maybe at a park, or maybe your favorite ride at an amusement park like Six Flags. All right, what is your favorite equipment or ride? And then see if you can describe the motion or the speed of that ride. So I'm a huge roller coaster fan, so I thought I would take us on a little roller coaster ride. All right, here we go. This is called the Iceberg. Oh, don't freeze on me now. Technical difficulties. Just like in class when I start something and it's not working. Let's see. There we go. No, we don't. Gotta love technology. Now everything's working. Here we go. Awesome. Do you love a roller coaster? Do you like that feeling when you get to the top of the roller coaster and as you start moving down? Well, that was short-lived. So you get what it is I'm trying to talk about. So hopefully most of you have been on some sort of roller coaster. And there are lots of different roller coasters you can look up on YouTube. Lots of different roller coasters. All right, so moving back. Or not moving back. The first thing you're going to do this week after you talk about roller coaster rides or equipments that you like is, of course, you're already watching the video. You're going to be reading Investigating Forces. Okay? All right, so this is Investigating Forces right there. Starting with this one. A mother hears a loud crash in the living room. She walks into the room to see her 7-year-old son looking at a broken vase on the floor. How did that happen? She asks. I don't know. The vase just fell all by itself, the boy says. You're right, says the mother. Oh, wait, it doesn't say that. The mother says, it couldn't have moved by itself. Didn't you learn in school that nothing moves without a push or a pull? Is what the boy says possible, or is his mother correct? In the following lesson, you will answer these and other questions about how pushes and pulls can change motion. What are some forces that can affect objects? A force is a push or a pull. There are several kinds of forces. Some forces are hard to notice. Other forces put on quite a show and are easy to notice. Some forces need to touch the thing that they act on, and other forces can change a thing without touching it, like maybe the difference between pushing a chair over or the wind pushing some leaves down the street. When someone pushes or pulls on something, it is easy to see the effect. You push on a bicycle pedal and the bicycle moves forward. The dentist pulls on a tooth, ouch, and the tooth comes out of the patient's mouth. Other forces may seem more mysterious. For example, a magnet. A magnet can both push and pull on another magnet. A magnet can also pull on something that is made of iron or metal. This happens because of the invisible lines of a force surrounding the magnet. Sound impossible? Remember that even if we can see the force, like in a magnet, it's still there. Even if we can't see it, it's still there. Gravity is another force. Oh, I guess I was going to show you. I do have some magnets here. All right. Let me be able to prop this up. All right, so I have a couple of magnets. Actually, I have one. This is the one that I used last week, right here. And it's got a light on the other side. I keep this on my refrigerator. And then here's my magnet from when I went to Alaska. And it is a pulling force. Those magnets are pulling on each other. Now, I do have some at school, the ones that line up in a long line. And some of those, when you push them together. Now, if I were to take this magnet off and turn it around the other way, then those would actually push each other apart. All right, so gravity. This is where I am right here. Gravity. Gravity is another force that may seem difficult to figure out. Gravity is a force that pulls all things with mass towards all other things with mass. However, gravity is actually a very weak force unless one of the objects is very big, such as planet Earth. Things fall to Earth because the force of gravity pulls on them. Gravity also holds things on Earth's surfaces. If it weren't for gravity, things would just float away into space. Gravity is always a pull and it is never a push. All right, reflecting on friction. Friction is a force that slows moving things down. Friction acts in the direction opposite to the motion. Friction can also keep things from sliding around. The materials involved help make this happen. The force of friction is greater when a surface is rougher. You can walk up a steep sidewalk because friction keeps your shoes from slipping. So you have the rubber on the bottom of your shoes. And then I was just noticing, like out here in my front yard, I have that pebbly kind of gravel stuff. It's all stuck together like a concrete, but it helps you keep from slipping when you walk. You might not be able to walk up the same sidewalk if it were covered with ice. And I know that I, for one, have fallen down on ice. Even when you have friction, like with these pebbles, like right out here, if it's covered with ice, it makes it a lot harder. The force of friction would be much less strong between your shoes and the smooth ice. All right, what do you think? A car is parked on a steep street. The car is not moving. When something is not moving, we know that the two forces are what are known as balanced. If something is not moving, then it is balanced. So right now I have my iPad in my hand and I am videotaping this and it's moving, which means it's not balanced. But if it was completely still, that means that it would be balanced. So for instance, like my phone that is sitting right here, or my magnet, or anything that is sitting on a table, all of these things are just balanced. This means they cancel each other out. Which force is pulling the car down the hill? Which force is balancing and keeping it from sliding? What are some ways in which forces affect objects? Even pushes and pulls are not, Aiden just commented on something for Fun Fact Friday. Even pushes and pulls are not totally simple. For example, forces always come in pairs. If you push on a large tree, nothing happens. If you try to pull the tree out of the ground, nothing happens. When you push the tree, another force is balancing your push. When you pull the tree, another force is balancing your pull. But where are these objects coming from? So think about this. When you push on a tree, the tree is actually pushing back with an equal force. The result is that the forces are balanced and nothing moves. Now, if it's a tree that is really small, like I have these big, huge trees like out here in my front yard. If I push on one of those big trees, nothing's going to happen. But I have these little bushes right here. If I were to push on one of those, and something would happen because that tree right there is stronger in pushing back on me, and that tree right there would not be. It's kind of working out well that I'm in my front room and you can see my front yard. All right, similarly, when you pull on that big tree, the tree pulls back. This happens for all forces. When the force of Earth's gravity pulls you to the ground pushes up with a force equal to your weight. So if not, then if you were on another planet that it didn't work equally like that, and gravity was pulling you to the ground, we literally would just be stuck on the ground all the time and we wouldn't be able to move around. All right, when the force of gravity, Earth's gravity pulls you to the ground pushes up with an equal force. So there are forces that are not always balanced, however. So when something is not balanced, it's known as unbalanced, and something has to change. And there are several different ways that things can be unbalanced. When something speeds up, when something slows down, when something changes the direction, is going one way and then goes another way, like when you kick a ball, or if something changes shape. If you have a balloon in your hand and you squeeze it and you change the shape of that balloon. These changes happen only when the force is acting. Also, while the force is acting, the change keeps increasing. For example, something will keep going faster if a force keeps acting on it. When a rock is falling, the force of gravity is acting on it because the force is always acting on that rock. The rock goes faster and faster until it hits the ground. I feel like this is not very, there we go. Almost to the end before it gets focused very well. All right, last paragraph. When you throw a ball, it speeds up until it leaves your hand. At that point, the force of your hand has no more effect on the ball, and the ball begins to slow down. The ball slows down because the force of friction between the air and the ball acts in the opposite direction of that motion. All right, and then you're going to come here. Monday continued. So you just got done reading Investigating Forces, or I just got done reading Investigating Forces, and thinking about how objects move around and the forces that are on those objects. So now we're going to go for a hunt somewhere in your house or outside for objects that either push, objects that pull, or both. You're going to look for and you're going to record those objects on the table on the next slide. And I'm going to ask that you have at least 3 objects of your own for each category. I want you to insert a photo, either a photo that you take or a photo from Google Images, and label the pictures of the objects in the appropriate box. You can put objects in more than one box if you'd like to, so if you have something that pushes and pulls. An example object has been done for you. So I'm going to go on to the next slide. Now, as of right now, when you open this first part will already be done for you, where it says examples, but I thought I would go ahead and show you what you could do for example. So you can just go around the house and you can try to find things that push or pull, okay? So for instance, I'm thinking to myself, okay, so this door right here, I am pulling my door right here. I'm pulling it closed, okay? I can pull it this way and I can pull it that way. If I think about a chair right now, if I sit in that chair, I'm not going to fall down. It's going to push up on me. Other things that you can pull. Hey, babe, somebody from the something's here. God, I visited, and my dog's going to go crazy. When you have a drawer, you can pull the drawer open and closed. Here's a puzzle that I'm working on right now. Okay, I can pick up a piece, so I'm pulling. I'm not doing a very good job of. There it is. Can you get her? Right now, my daughter is trying to pick up my dog. Oh, she's in trouble now. I can pick up the puzzle right here. Why can't you see my hand? There we go. I'm picking up the puzzle, so that's a pull. If I go and I find the place where it goes on my puzzle, all right, I can push it down. So there's lots of things that push and pull. So what you're going to do is you're going to find different things around the house that push and pull, and I'm going to show you how I want you to put those onto this chart right here, okay? All right, so pushes and pulls. So I'm going to put the chair right here. So I'm going to say, okay, I took a picture of my chair with my phone, and I sent it to myself. And when I sent it to myself, I put it on my desktop. So my chair is basically like right there, okay? All right, so I'm gonna open that back up and I'm gonna put in a picture right there of my chair. Okay, the way that I'm gonna do that is insert, image, and then I want to upload it from my computer. So when I do that, should pop up a box. It's going to let me upload. Of course I say that and then it won't let me do that because it's taking forever because my internet is having issues. Okay, and so it's on my desktop and I just called it chair, and I can open it up and then boom, there's the chair. Now that's a really, really big chair. I obviously don't need it that big. So I'm gonna come over here, I'm gonna make it smaller, and I'm gonna use this to turn it around. And now when you see this, when you open it, it will already be there for you. So that's the picture of my chair. And I'm gonna insert a text box. And I'm gonna drag it right there. And I'm gonna type the word chair. All right, and then I'm gonna just kind of move that over so that it's right there. All right, and then there's chair. All right, now something that pulls. I showed you a drawer, but one of the things that I thought about was like a bag of chips. You know when you have to pull a bag of chips open? So another way that you can get an image in here is you can just open up a tab, which is what I did here, and then I typed in pulling open a bag of chips, and I clicked on images. And so I wanted to find a good image for pulling open a bag of chips. Oh, that's a good one right there, because you pull open the bag of chips, and it pops open like crazy. All right, so I'm just gonna right click this right here and copy that image. And then when I go back to this, I can just paste that image. And there's that big old bag of chips. And I'm gonna put it right there. All right. And then I'm going to insert text box. I'm going to type in bag of chips. All right, and then something that does both would be a door. So you can pull on a door and you can push on a door. So I'm going to do insert image. This is another way you can find an image. You can search the web, and this pops up over here, and I'm just going to type in door. And when I type in door right there, there's all these different doors that I can basically just drag over. So basically like any kind of front door, okay? All right, so I don't know. This is just a clip art kind of door. There we go. Drags that over. I can X that out. And obviously that's too big, so I'm gonna make it smaller. And I'm going to insert. There's some people like working on the there's image, text box, and door. All right, and that was how I was able to add those things. So now at this point, you need to go around your house and you need to find something that pushes, something that pulls, and then something that does both. So there are 3 that are here for you. Okay, make a little bit more room on that one. There are 3 that are here for you. I need an example of something that pushes, something that pulls, and something that does both. And you can enter the images with Google Images or something that you find or whatever you need. All right, and I think that is it. Is that tomorrow's? Yeah, that's tomorrow's. So that is it, and this is your activity for today. All right, thank you, and have a great day. Miss you guys. Bye.